and this is 137. So we have g of x to the third for x less than or equal to 1, and 3x minus 2 for x greater than 1. In part A, they're asking us to find whether it's continuous at x equals 1. That's our first part. So first question is this function continuous everywhere?
Yes.
Yes, it's a polynomial function. Very good. Is 3x minus 2 continuous everywhere?
Yes.
It's a polynomial function. So the only concern we have is x equals 1. How do we check continuity at a point? Continuity at a point. Anyone?
The right-hand limit and the left-hand limit.
The limit from the left, the limit from the right must equal what else?
They must equal the same thing.
Yes, and what else? Equal to what else? Very important.
They must be equal to the value of the function at that point.
Excellent. So I have the limit as x approaches 1 from the left must equal the limit as x approaches 1 from the right and must equal f of 1. If these three do not exist, all three, or are not defined, or whatever else, the function is not continuous. Okay, so the limit from the left is from what? The limit from the right is from what?
The limit from the left is x to the third, so 1 to the third.
And the other one, obviously. So can anyone give us this limit? Very good. Can anyone give us this limit? Good. Can anyone give us f of 1?
1.
Which of the two branches are we going to use? Top or bottom?
The top branch.
Right, because of the equal symbol. Is this function continuous at 1?
Yes, it is continuous.
Part B. Verify that the function is g differentiable at 1, yes or not. I don't know. It could be, but maybe it has a cusp or a corner, and then it will not be differentiable at that point. So we have to find, so in part B, differentiable at x equals 1, and the answer is right now, no clue. Okay, so we will find the g prime of x for x cubed. We will find g prime of x for 3x minus 2. So one from the left, one from the right, from the left of 0 and from the right of 0. And we'll see whether they are the same. If they're not the same, then we will say the slopes are not the same. The slope has to be unique. So a function is differentiable at this point if it has only one slope. If it has two slopes, one here and one here, at this point the function is not differentiable. One option is to graph the function and see what happens if it has something like this, but better, let's find g prime of x. It's not an easy task because of x cubed. So let's find g prime of x, but I need this for the next chapter, the next section anyway. So let's do it now, and we'll understand, we'll draw a conclusion. I still have time, right? 7 minutes, at least one of them I can finish in 7 minutes. So how do I start? We have to get used to it quickly, so we don't forget this. What do we?
Limit.
Very
Limit
good.
h to 0.
Very good. As h approaches 0 from Yes, the same thing over and over and over. And I continue here. So it's limit as age approaches 0. Can anyone tell us what to write next? And we are looking at x cubed.
Is it x plus h cubed?
And since it's from the left, so we can write the left. Okay, sorry. Yes, thank you very much. X plus h everything cubed minus indeed x cubed divided by h. Okay, I'm going to create this calculation because I'd like to finish in 6 minutes and not hold you over because I don't like that. So I'm just going to show you the formula for this. How do you determine x plus h cubed? You just multiply x plus h squared. You expand it as we know with the formula, and then you will multiply again by x plus h. But I'm going to give you the formula, the answer directly. Plus 3x squared h plus 3x h squared plus h cubed. Please verify that this product is that for yourself later. Okay, so I'm here now with a square, so you know where it's continuing. So limit as h approaches 0 from the left. I copy all this, x to the third plus 3x squared h plus 3x h squared plus h cubed and minus x cubed. What has to happen next? And this we know.
All the terms without h, we can't do that.
Absolutely. We know this for a month already. Thank you very much. And the next step that must happen for sure.
Factor out an h from the numerator.
Excellent. Because we know that this has to happen. And what is left at the top?
Would it be limit as h approaches 0? Then it would
The
be
top.
Yeah. Oh, sorry. So it'd be h 3x squared plus.
We took
3.
out h from the top.
Yeah. So would it be 3x squared
Indeed.
plus
Yes.
3xh
Indeed.
plus h squared?
Great job. Now the limit. And this is the time we drop the limit operator. Now, only once at the end.
What do we, 3x squared plus 3xh? 5?
H approaches 0. 0. 0. What is the answer? 3x squared. Very good. So please remember, whenever we differentiate or find the derivative of x cubed, what is the answer?
Yeah.
What is the answer?
3x squared.
That's it. We just determined it. Carved in stone to remember forever. The derivative of x cubed is 3x squared. Okay? So now let's see the other one. I know I only have 3 minutes left. I'll do whatever I can in 3 minutes. So then the other one will be the g prime on the other side, which will be limit as h approaches 0. If you want, it doesn't matter. It's not going to change anything. So it was 3x, what was it? I lost my page. Okay, right here. So 3x minus 2. So this is 3x minus 3h, no, 3x plus 3h minus 2 minus 3x plus 2 divided by h. Of course, the same thing happens. So this is 3. After I simplify the h, it's just one number. So we got that g prime of x is 3x squared for x less than 1. Do not copy the equal symbol. And we got that this is 3 for x greater than 1. I will put the equal symbol if the function is differentiable. What do you think? From the left of 1, so is the limit from 3x squared as x approaches 1 from the left, is it the same with the limit of 3 as x approaches 1 from the right? If these two limits are the same, I will say the function is differentiable at that point. If they are not the same, then I will say they're not. The function is not differentiable at 1. It is continuous, but not differentiable. What is this limit?
9.
What did we plug in?
Oh, 1, so 3.
Good. What is this limit?
3.
Good. So now I can guarantee g of x is differentiable everywhere. Not just to the left of 1 or to the right of 1. It is differentiable, if you want, at x equals 1 for sure.